So yeah, I'm really excited to share my work on foundation models for medicine. Yeah, I think as we are all aware of, there's been a lot of progress in the field of AI, and especially with the rise of generative AI. And foundation models. I think we all know, of course, how ChatGPT kind of started this whole revolution, I'd say. We had one of the first popular foundation models with ChatGPT that could take in text and produce responses. People have also been developing a bunch of different sort of assistants for different domains. So of course, one of the common ones was in programming, where we had tools like GitHub Copilot. But of course, people have been developing tools for other domains like finance and law and education. So various different domains, people have been developing foundation models for these purposes. And then not only just with text, people have been also exploring other modalities and combining modalities. So we have multimodal models, which, for example, this clip model that can take in images and text, as well as some of these lava models that can also do the same. On top of that, we have models that are able to generate other modalities, such as generating images, like with the stable diffusion models, or generating audio, or generating video. So yeah, overall, we've seen a lot of progress with all these different models. What I'm most interested in is, of course, people have been developing applications of these models for different domains like law and finance and all these different domains. But the application that I'm interested in and the domain that I'm interested in is in medicine. And I think it's important to ask if these models are relevant to medicine and how these models can be used in medicine. So if you look at some of the models so far in some of these foundation models and look at how much sort of medical knowledge they currently have, it kind of varies per model. So for example, some models, like some of these image generation models here, so this is one of the stable diffusion models, they get the overall sense of maybe what you're trying to generate, but it's still very unrealistic in terms of what they're generating. They have very limited medical knowledge. Other models like ChatGPT, we know people have been using this for answering medical questions. Maybe you hear stories of patients trying to use it to answer their medical questions. But I think while there is some medical knowledge in some of these models, I think these models can be taken much further. And this is a question that people have been trying to ask: is how far can we take these foundation models in the medical field? And the question is if we need generalist models versus specialist models. So what I mean by that is some people have been arguing that we actually have to fine-tune these models on medical data sets and kind of further improve its performance and in order to be able to perform these medical tasks accurately. And so some papers have suggested that you need to do these sorts of fine-tuning in order to get state-of-the-art performance, while other papers are just doing something like prompt engineering GPT-4 and getting state-of-the-art on a whole bunch of medical benchmarks. So it's been a question whether or not if you're just training on a whole bunch of information and a whole bunch of data from the internet and from a variety of sources, whether or not that has enough medical data and that's enough to actually just train models, and you just have a generalist foundation model that can do everything, including medical tasks, or if we need specialized models for medicine. I personally think that there is a need for specialized models for medicine, specifically because there is a significant difference between the sorts of data that we see in medicine compared to other sorts of data, like natural data. So for example, I think this is very apparent when you look at medical images versus natural images. You can see how the medical images have a variety of differences from other sorts of natural images. So if you were to train like an image generation model, you can see like if it's going to be trained mostly on these natural images, it's not going to understand medical images very well, and it's not going to perform there very well. So there is definitely a need to train specialized models on medical data. The same is also true for medical text, for example, as well, because the medical language is like its own language too. So it makes sense that you may need to train a sort of separate language model for medical applications. So in general, I think there is because of these differences in natural data versus medical data, I think there is a need for medical specific foundation models in order to be able to address some of these medical tasks. And so with these foundation models, the goal is to hopefully be able to perform a whole bunch of tasks. So these models are able to kind of, you train them with the ability to perform a variety of tasks. This could be things like answering questions about patient healthcare records, or analyzing medical images, providing diagnosis, all sorts of tasks that you can perform with these foundation models. And so hopefully, I've convinced you guys that this is a an interesting direction to work in, developing foundation models for medicine. But I think what's more important to realize is that, in my opinion, at least, it's not just important to build foundation models, it's important to build open foundation models for medicine. And there are a variety of reasons why open foundation models, I believe, are the future for medicine. So of course, with what I mean by open models is that we're releasing the weights of the models, we're releasing the data sets, how these models are trained, all of that information is available and all of that information is accessible. And what this enables is that now we can, for example, locally deploy these models in a privacy-first way, which is of course very important in healthcare settings, like in a hospital where the privacy of the patient information is very important. On top of that, if everything is open in terms of how the model is trained and the data sets and the model weights, this builds complete transparency that builds trust with all the stakeholders involved, from the doctors to when it comes to regulations and getting these sorts of products approved. So it's important to have that transparency. Another issue with some of these proprietary models is that sometimes models like GPT-4, they're continuously being updated. So, and you don't know what version of the model you may necessarily be using. And so the model behavior may change over time as well. So you don't have a very consistent, the model that you're using is not going to have very consistent behavior. But if you are able to have access to the actual model, the open model, you know exactly what model you're using. This is much more reliable and much more consistent that you're using, this exact model, open model that you have. On top of that, these models can be customized to specific populations as well. And so, for example, if you're working in a hospital environment and maybe that hospital has a specific demographic, you can fine-tune a model to perform better with those sorts of demographics. That's not necessarily possible if you have a proprietary model that may not be very flexible. So for this reason, I founded medARC to focus on the development of open foundation models. We try to do this in a very collaborative approach. So we actually work with a lot of academic institutions like Stanford and Princeton. As I mentioned, we're focused on building foundation models, and we try to release our models and our data sets and publish our results, and overall just trying to build a community for medical AI research. So we have a few projects that we've been working on. This first project was a collaboration led by Stanford that we were a part of, where they fine-tuned one of these image generation models on chest x-rays, and you can basically generate chest x-rays with this image generation model. It can be used to generate synthetic data for training downstream chest x-ray diagnostic classifiers, or maybe it could be used for medical education applications as well. So there's a variety of applications that still haven't been fully explored yet with these sorts of models, but it's a very interesting application of image generation for medicine. Another interesting paper we worked on is training a multimodal model for chest x-rays. So we trained a language model and also on clinical notes and radiology reports, and also a x-ray vision encoder, and combined them in order to create this multimodal model. And this was trained on a huge data set of instruction examples for chest x-rays. And so basically you can give it a chest x-ray and ask questions about the chest x-ray, and it can answer a variety of detailed questions and even generate radiology reports and things like this. Another interesting project, I think is one of our, main projects at medARC, is this sort of fMRI to image reconstruction. Sometimes we like to call it mind reading. Basically, we have a patient that is under the fMRI machine, and the patient is looking at an image, and we are recording the brain activity with the fMRI machine of the patient. And based on just the brain activity, we are able to reconstruct the image that the patient is viewing. And so we're able to utilize the latest advances in generative AI and multimodal models. So we're using the latest diffusion models, we're using some of these multimodal models like CLIP, and we're utilizing all these models in order to be able to do this sort of reconstruction. And you can see here how impressive these reconstructions are. You can see on the left-hand side the image that is seen by the patient, and then our reconstruction from just the fMRI signal. And you can see it's very, very close to the actual image. And you can compare it to the previous methods where, these previous methods were not, it was still like, the time when generative AI was kind of, it was still not as popular at the time. So, there were some of these previous methods were not using generative AI approaches. But with our multimodal and generative AI approaches, we were able to significantly beat the state of the art for this sort of task. On top of that, we've been further improving our results in this fMRI to image reconstruction, and we've also been able to reduce the amount of data that's actually needed to perform this reconstruction as well. And this will also enable this sort of work to be more practical as well. So we've been really excited by this, and now we're also moving into mental imagery reconstruction, which is basically not just what the patient is looking at, but what the patient is imagining, and trying to reconstruct what the patient is imagining as well. And so this is the next kind of direction that we're working on. And again, trying to use some of these image generation foundation models in order to be able to do that. And finally, a new avenue that we've been exploring is language models for medicine. So, I've been talking about all these other examples because I really wanted to highlight more of like how other models apart from language models can be used for medicine, how other approaches outside of language models can be used. Because generative AI is quite broad actually, but the language model space is also quite interesting as well. And so we've been also starting to explore this as well. And so right now we've mostly been doing evaluation of the current state of the art and just kind of understanding the landscape currently. And we've actually been very surprised to learn that some of these open source language models are already catching up to the proprietary models in terms of performance on medical question answering and medical task benchmarks. And the open source models continue to get better and better. And so we think that by fine tuning some of these open source models, we'll get even better performance and hopefully even beat some of these proprietary models while keeping it open. And so this is something that we're currently working on right now actually. So overall, I think that generative AI has a lot of potential in medicine, and not just with the language models, but even in other space like multimodal models and image generation. And of course, I think that open models is the path forward for applying generative AI in medicine, and I think there's a lot of potential there. So with that, I'd like to end. If there are any questions, feel free to visit our website and also check out our Discord server. We have this Discord community for medical AI research, and lots of great people over there. So feel free to also ask us questions there, or feel free to contact us on LinkedIn and Twitter as well. But yeah, with that, I'd like to end the presentation. Thank you all for joining.